Okay, so Sandra and I will be presenting over viral vector vaccines. So what are viral vector vaccines? This is part of artificially acquired active immunity. What happens is they take an inactivated virus, take advantage of the mechanisms of the virus entering the cells and proliferating, and they use that genetically alter it, and they introduce a gene instead of a viral gene, one to replicate and protect us against other pathogens. This also, like I said, mimics the viral infection route. And Does somebody that has a microphone on? Hey Sandra, could you mute your mic? Perfect. Perk of this procedure is it is very cost effective, both to manufacture and to give. So what can they be used for? These are, again, to protect against diseases and to prevent outbreaks and pandemics like we have just seen. Diseases that they have used this technique for are Ebola, Zika, HIV, malaria, and most recently SARS-CoV-2. So where is it performed? The vaccine itself is going to be made in and manufactured in biopharmaceutical labs such as Pfizer and AstraZeneca and all those other ones that you've probably heard of. What they do is they're going to grow cells and substrates. That way that the viral genetically modified virus can be extracted from those into the vaccine and be given. These have to be stored at very low temperatures in order to not denature the virus. And these will be stored in clinics, hospitals, and anywhere where the vaccine is going to be given. So cells and structures for the viral vector vaccines. These activate the cytotoxic T lymphocytes to eradicate the infected virus, the virus-infected cells. So the T cells, cytotoxic T cells are seen here. This, they will also then activate an antigen-specific cytotoxic T cells, like we mentioned, CD8, and they will become effector T cells. Then, later on in the cascade, it will activate macrophages and natural killer cells to eradicate the intracellular pathogen altogether. So then I will pass it to Sandra to go over the materials and methods.
So the materials and methods, the way it works is you use a whole virus, bacterium, and you use parts of that to trigger the immune system or just genetic material. In viral vaccines, you're using the whole virus that doesn't cause any illnesses. The spike protein DNA is placed inside a modified version of a different virus that doesn't cause any illnesses, as stated earlier. It delivers the DNA instructions to your cells, and this virus is called the vector. The viral vector vaccines, the viral vector vaccines use a modified version of a different virus, and that vector delivers protection to the actual virus. And viruses have been used as vectors in diseases such as influenza and measles. If the background is too loud, let me know. I don't know if you guys can hear me well, but the mechanism of action behind viral vaccines is you have the virus, and the viral protein, which is the antigen, has genetic material not attached to it, but you can kind of see on the figure there. You go through gene coding, and that gene coding is then transferred to the adenovirus, which is used as a Trojan horse to deliver genetic code into cells. That then transfers over to the viral protein, which is the cell's production of the viral. Yes, that teaches the body to identify the antigen. And then that transfers over to antibodies, which targets a specific antigen. Clinical application of viral vector vaccines. So adeno-associated viral vectors, which is AAV vaccines, have been used to treat diseases such as eye diseases, muscle diseases, and infectious diseases. Some AAV vector vaccines can induce strong and lasting antibody responses after just one dose. Some can possess a low immunogenic profile when compared to other viral vectors. Recent studies, according to a study that took place in 2022, participants who've received the 2 standard dose of the vaccine efficiency was 62.1%. And whereas those who received a low dose as their first dose of the vaccine efficiency was higher at 90%. Overall, it's highly effective in preventing severe diseases, which include death from COVID-19. These are our sources. Any questions?